Viewers, welcome to Mass Maestro. Thank you for joining in. In this video session, I will be discussing with you problem set number 2.2 of Erwin Kreyszig's Advanced Engineering Mathematics. Questions will be from 21 to 30. Okay, and the first question is appearing on your screen. These questions are all initial value problems. There are initial conditions which are given, and we have to find the exact equation for them or exact function of them. And what I can see, majority of them are actually second order ordinary differential homogeneous equation. We will be solving them as such. Okay, the first question is given y double prime plus 25y is equal to 0. In all of them, as regular, we will be first forming or establishing an auxiliary equation, and then on the basis of that we will be actually getting our solution with the two constants, and then using initial value problem we will try to find out the value of those two constants. This equation is the auxiliary equation actually will be d square plus 25 is equal to 0, and this will give us d is equal to plus minus of iota 5 iota, and hence the general solution for this will be actually c1 cos 5x plus c2 sin 5x. Okay, and now we have to use this condition. The first one we can use right here only directly, because it is with the equation. So it says that when the value of x is 0, the value of y will be 4.6, which means we can write 4.6 is equal to c1 cos 50 will be 0, and then c2 sin 50 will be sin 0. Here cos 0 is 1 and sin 0 is 0, so this will go off and we will get only c1 is equal to 4.6. And then in order to apply the second initial value condition, we need to actually differentiate the equation found here, which is equation 1, and by differentiating it once we get y double prime, and this will be minus of 5c1 sin 5x plus 5c2 cos 5x. Okay, and it says when x is 0, this value is minus 1.2. So we can substitute here minus 1.2 is equal to 5 minus 5. c1, if you wish, you can put it from here, but since at 0 the sin 0 will become 0, so there is no need of actually computing this at all here. So we get nothing, but now we can directly keep it 5 c2 is equal to, this will be cos 0, and cos 0 will be 1. So value of c2 will be actually minus of 1.2 divided by 5. c2 will be minus of 0.24. Therefore our required answer will actually be y is equal to 4.6 cos 5x, and since this is minus, we can directly write it minus instead of writing it plus minus. Okay, so or you can write plus and in the bracket minus 0.24, and then this will be sin 5x, or you can write 4.6 cos 5x minus of 0.24 sin 5x. And friends, actually this is the answer. Okay, so let us move to the next question now. Next question is question number 22, y double prime. Actually in this question we have to refer the problem number 4, and problem number 4 was actually this given here, and then the initial conditions are given here as y at 1.2 is equal to 1 and y prime at 1.2 is minus 2. We have to use these initial conditions here. First of all, we need to form the auxiliary equation of this, and this will be d square plus 4d plus pi square 4 is equal to 0, and use quadratic equation for simplification. This will be 4 square, which is 16 minus 4 of this, and this will be pi square plus 4 divided by 2, or minus 4 plus minus, this will be 16 minus 4 pi square minus 16, and we will get here this will be 2 pi iota. So here actually the solution of the auxiliary equation is actually complex. So we have two roots of the equation. This will be minus 2 of plus pi I and minus 2 of minus pi I. So what is be our homogeneous general solution? This will be y e to the power minus 2x, and then in bracket we will get c1 cos pi x plus c2 sin pi x. Now apply the initial value conditions. At x is equal to half, y is 1, right, 1, and x is half means this is half is e to the power minus 1, and here c1 cos pi oblique 2, and here c2 is sin pi oblique 2. When you substitute x is equal to half, the value will be like this, and this will get us, this is 0, so this will go away, and we will be left with c2 is to 1 is equal to this e. If we take this side, will become e1, e, simply e. So c2 is e, and then to apply the second initial value condition, we need to differentiate this equation. Okay, so this will be y prime is equal to e to the power minus 2x. This will be pi c minus pi c1 sin pi x plus pi c2 cos pi x, plus this will be minus of 2e to the power minus 2x, and this will be as it is, c1 cos pi x plus c2 sin. Now this is minus 2 at x is equal to half. Okay, so this is minus 2, this is minus 1 here. If we substitute half, minus 2 is to half will become minus 1. I kept it here. Then this will be minus c1, and sin half will be 1, so I can write it half. And here I can forward write 0, as cos pi oblique 2 will become 0. This will be minus 2 e to the power minus 1, and at 0 this will be c1, and this will be 0. Minus 2 1 oblique e minus pi c1, this is 2 oblique e c1. Multiply the entire expression with minus 1, we will get 2 is equal to pi c1e plus 2c1e, or c1 is equal to 2e divided by 2 plus pi. So our general solution here will be y is equal to e to the power minus 2x. This will be 2e pi plus 2 cos pi x plus c2, what we obtained is e sin pi x. This is the answer, friends. So we will be moving to our next question now. Next question is, this appears to be pretty simple because our auxiliary equation will become d square plus d minus 6 is equal to 0. and we have to split this one in a way that equal to minus 6. So we can write d square minus 3d plus 2d. No, we can write plus 3d minus 2d minus 6 is equal to 0. This gives d plus 3 minus 2d plus 3 is equal to 0, and this will give us nothing but d is equal to this is minus, so this will be plus, and this is plus, this will be minus. So we have got two roots, which is 2 and minus 3. So our equation will become actually y c1 e to the power 2x plus c2 e to the power minus 3x. Use these value conditions. At x is equal to 0, y is 10. So we can write c1 plus c2 is equal to 10. And the second condition is actually this is prime. Y prime 0 is equal to 0. So we will have to differentiate it. Y prime is equal to 2c1 e to the power 2x minus 3c2 e to the power minus 3x. And then we substitute these conditions. Y double prime is 0. At x is equal to 0, so this gives 0, 3, 2c1 minus 3c2 is equal to 0. Now substitute any one of them here, right, in this equation. This is equation A, this is equation B. I choose to C2 is equal to 10 minus C1 here. 2C1 minus 3, 10 minus C1 here is equal to 0. Will give us 2C1 minus 30 plus 3C1 is equal to 0, or 5C1 is equal to 30, or C1 is equal to 6. Therefore, C2 will become 10 minus 6 is equal to 4. So we have to simply substitute it here to get our answer as y is equal to 6 e to the power 2x plus C2 4 e to the power minus 3x, and this is the answer. Okay, let us move to the next question. Question number is 24. The auxiliary equation is 4d square minus 4d minus 3 is equal to 0. This can be written as 4d minus 6d plus 4d minus 3 is equal to 0. 2d minus 3 is equal to 0. 2d minus 3 here plus 2d minus 3 is equal to 0. 2d minus 3 plus 2d minus 1 here. 2d plus 1 is to 2d minus 3 is equal to 0. This gives d is equal to minus half and 3/2. Our equation will be actually y c1 e to the power half x plus c2 e to the power 3/2x. Now initial conditions, at x is equal to minus 2, y is e. So we can write here c1. This is minus 2 multiplied by half is 1, and e to the power 1 is just e, and then multiplied by minus 2 will be here c2 e to the power minus 3. This will give what? c1 plus c2 e to the power minus 4 is equal to 1, and then apply the conditions. Y prime is equal to half of minus 2 is this is e, and plus 3/2 c2. If I multiplied with minus 2, this will become e to the power. This will give us 1 is equal to c1 minus of 3 e to the power 4 c2. So we have these two equations, one is here and another is here. We can find out what are the constant values. So first of all, c1 will become how much? 1 plus 3 e to the power 4 c2 is equal to 1 minus c2 e to the power 4. I take it this side and this becomes c2 4 e to the power e to the power 4, and this is 0. This gives us c2 is equal to 0. And then what will be the c1? c1 will be just 1. Therefore our equation will actually be just y is equal to c1 e to the power minus half x, which is nothing but 1 e to the power minus half x. So friends, now we have come to problem number 25. Problem number 25 actually is simple. The auxiliary equation will be d minus 1 is equal d square minus 1 is equal to 0, and this will give us d is equal to plus minus 1. Therefore our equation will be y c1 e to the power x plus c2 e to the power minus x. Right, now we have to use initial condition at x is equal to 0, y is 2, which actually means c1 plus c2 is equal to 2. This is one equation, and to apply this we need to do the first derivative of this equation. So we get y prime is equal to c1 e to the power x minus c2 e to the power minus x. And then at x is equal to 0, this is minus 2. If we look at here, at x is equal to, this will become 1 and this will also become 1. So we have c1 minus c2 is equal to minus 2. Then solve them. 2c1 is equal to 0, c1 is equal to 0. Therefore c2 is equal to 2. So the exact general solution for this will be y is equal to 2 e to the power minus x. This will be the answer. Question number 26. Question number 26 is simple. That only thing is that they have given one extra unknown here, which is k. We will leave k as it is. Our initial equation will become delta square minus k square is equal to 0, which means d we will have plus minus of k, and our general solution with unknown constants will be c1 e to the power k plus c2 e to the power minus k. Okay, and apply initial condition at x is equal to 0, y is 1, so we can keep it 1 here, and 0 will be 1, and here 0 will also become 1. So c1 plus c2 will be 1. Okay, now we have to take the first derivative of this equation. This is 2, this is 1, and first derivative will be y prime c1k e to the power k. This minus will come out and it will become c2k minus c2k e to the power minus k. And exactly we will apply the same method, put x is equal to 0 and we get y is equal to 1, 1, and here it will be ck1 minus c2k, or c1 minus c2 is equal to 1 oblique k. This is, we need to solve these two equations to find the value of c1 and c2, right? So adding both of them, we get 2c1 is equal to 1 plus 1 oblique k. This gives c1 is equal to half of k. Therefore, c2 will become 1 minus c1, which is half. Hence, our general solution will become, okay, this is the answer. Now let us move to the next question. So we will solve question number 27. Question number 27 is in reference with problem number 5 that we have already solved. In this case they have given initial value condition and we need to find the exact solution of this, or actual solution for this. So our auxiliary equation will become d square plus 2 pi d plus pi square is equal to 0, and this will give us minus of 2 pi plus minus 4 pi square minus of 4 is to 1 is to pi square divided by 2 is equal to minus pi. So this is the case of equal and real roots. So we will have two roots of minus pi and minus pi. So our equation will be what? Y is equal to c1 e to the power minus of pi x plus c2 x e to the power minus of pi x. Okay, to make it linearly independent, we have to write this way. Now use the first initial condition, which is y is equal to 4.5 when x is equal to 0. This clearly brings this down from the equation, because x, the moment we put, the entire expression will become 0. So we get c1 is equal to 4.5 straightforward. Okay. For finding c2, we may have to actually find the first derivative of this, and this is y prime is equal to minus of minus pi c1 e to the power minus x, and this is plus c2 e to the power minus x minus of c2 pi x e to the power minus x. At x is equal to 0, this is minus 4.5 minus 1. So we can write minus of 4.5 pi here and minus 1. Substitute 4.5 in place of c1 here, and we will get minus of 4.5 pi. And then x is equal to 0, this expression exponential component will become 1, and this will be just c2. And since x is a multiple here, this expression will fume away, it will not be there. Therefore, in this case we get minus 4.5 pi cancels this minus 4.5 pi here, and our equation will become c2 is equal to just minus 1. So we can write our final equation as y 4.5 e to the power minus pi x minus of c2 is 1, we can leave 1 and directly write x e to the power minus pi x. This will give up 4.5 minus x to the power e to the power minus pi x. Okay, and this is the final solution for the given problem. Now let us move to question number 28. This is little calculative. You may need to actually have calculator to solve it, and we can write it 8y double prime minus 4y prime plus 2y prime minus y is equal to 0. This can make it 8, and our equation will become then 8d square minus 4d d plus 2d minus 1 is equal to 0. 4d minus 2d minus 1 plus 2d minus 1 is equal to 0. 2d minus 1 is 2. 4d plus 1 is equal to 0. And therefore the roots of the auxiliary equation are 1.5 and minus of 1/4. Okay. Therefore equation will be y c1 e to the power half x plus c2 e to the power minus of 1/4x. Okay. Apply the first initial condition, y is equal to minus of 0.2. We can write minus of 0.2, and then at both places we put x is equal to 0 will give us c1 plus c2 is equal to minus of 1/5. Then first derivative we need to find for this one, y prime is half of c1 e to the power half x minus 1/4 c2 e to the power. Okay, I think this is clear. And minus of 0.3 at x is equal to 0. This is half c1 of minus 1/4 c2 is equal to minus of 0.325. Solve this to get our answer. 2c1 minus c2 is equal to minus of 1.3 to this is c1 plus c2 is equal to minus of 0.2. 3c1 is equal to minus of 1.5 gives us c1 is equal to minus of 0.5 or minus half. Therefore c2 is equal to minus 0.20 minus c1 is plus 0.5. So therefore our required final equation will be y is equal to minus half e to the power half x plus 3/10 e to the power minus of 1/4x. This is the answer, friends. Okay, so let us go to the next problem. Problem number 29. This is again, we have already done it. I think problem number 29 earlier we have done problem number 15, but still we will do it here. And auxiliary equation is d square plus 0.54d plus 0.0729 pi is equal to 0. B square will be this one minus 0.2916 minus this is little calculative. Once we do this, this will be cancelled, and this will be minus 4 pi actually. So we get here minus of 0.27 plus minus 2 square root of pi I. Hence our equation will be e to the power minus c1 okay. Now we can apply the initial value condition to find the values of C1 and C2, which are unknown constants here. So at x is equal to 0, y is equal to 0, so we can put it 0 here is equal to, this will become 1 and this will become C1, this will become 0, so C1 is actually 0, and for other variable we need to differentiate. This becomes minus of 0.27 e to the power minus 0.27x So we have come to problem number 29th now. I have actually, this is quite complex, so I actually solved it first before recording it so that time is not wasted. This is the auxiliary equation that is formed, and the 29 number question is actually based on question number 15 that we have earlier done, okay? And these are the two initial conditions which are given. One is here and another is here. So when we make auxiliary equation and solve it for solve this quadratic equation for D, we will have a complex root for this with both real here and imaginary roots. So we know as per the rule, if real and imaginary roots are there in a complex form, then our solution will actually become this, which e to the power, the roots which is real will be taken, and then in bracket C1 plus C2 will be written in this trigonometric combination of cos and sine, which will be based on the imaginary root, which is just a square root of pi here, okay? Now we will have to apply the initial value conditions here. So you can see when value of x is 0, y is also 0. Which means if we put x 0, this will become 1, this is already 0, and when x is 0, this becomes, the entire combination here becomes 1, which means we will have actually C1 here, and with x is 0, sine of 0 will be 0, so this is actually, this component also becomes 0. So we will have this 1 and this 0, so our value for C1 will automatically becomes 0, okay? Now we will have to find C2 by actually differentiating the found equation once, and y prime is obtained in this form. We will have to apply actually product rule here, keeping u here and v there, and we know uv prime is equal to u v prime plus v u prime, and we will take this method to differentiate and make an equation, and then we will have to substitute the value of x is equal to 0 and y prime is equal to minus 1, not minus 1, 1. So I substituted y is equal to 1 here, and wherever there is x we will have to substitute it 0. So in this, since we have already obtained C1 is equal to 0, this portion will become 0, and this will become 0 because of the sine square root of pi x. The moment x is 0, this becomes sine 0, and sine 0 is 0. So this entire section will go off, okay? And then in the second part, here if sign is 0, this will become 0, so this also is not available. And when this is actually not, this is part of the cos, I think, like this. So we get here it is 0, and here the square root of pi c2 cos 0 will be 1, and then e to the power minus of 27x when x is 0, this is also 1. So we get a square root of pi c2 cos 0, which is nothing but a square root of pi c2, and the square root of pi c2 is equal to 1 will be obtained, and from here c2 will be obtained as 1 oblique a square root of pi. So we will take this and substitute, and we will get this particular answer. I think this answer is perfectly all right. You can take the 1 oblique square root of pi outside, and this can also be written as e to the power minus of 0.27x divided by a square root of pi, and then sine a square root of pi x. Okay. So now we can move to next question, which is probably the last question of last question of this section, which is question number 30. Question number 30 is, form here the auxiliary equation 9d squared minus 30d plus 25 is equal to 0. D will be 30 plus minus 900. Minus 4 is to 25 is 100, is to 9 is 900. So we have a case where we are going to get equal roots. Five oblique 3. So our roots are D 5 oblique 3, 5 oblique 3. Therefore, our equation will become y is equal to c1 e to the power 5 oblique 3x plus c2x e to the power 5 oblique 3x. Let us use the initial condition at x is equal to 0, y is equal to 3.3. So we can write c1 plus c2 is equal to 3.3. Not c1 plus c2, sorry. This x 0 will make it 0, this will not be there. So we can straightforward get c1 is equal to 3.3, and then we differentiate this equation 1 once to get y prime is equal to 5 of c1 e to the power. Okay, use x is equal to 0, this will become 1. 5.3 is to 3.3 e to, this is 1, and this is 10 plus c2, this will become 1, and this will become 0. So we have c2 is equal to 10 minus 1.1, 5.5, 4.5. Therefore, our required solution for this will be y is equal to 3.3. This is the answer. Right, friends, we are done with this section of problem set 2.2, which is question number 21 to 30, and I'll be back with new video solving more problem. Meanwhile, if you have not subscribed to my channel, I would request you to kindly subscribe to my channel, and if you like the video, kindly hit the like button and share the video with your friends. Till then, bye bye.